All right, so we are working on solving quadratics, and there's a great idea for solving quadratics, which is to use the idea of a perfect square. And so I hope you're familiar with the idea of a perfect square as a number. We're just going to take that idea and push it a little further. For example, 25 is a perfect square because it's 5 times 5. 49 is a perfect square because it's 7 times 7, but the number 50 is not a perfect square because I can't use a whole number times itself to get 50. 7 times 7 is 49, 8 times 8 is too big, so I'm out of luck. So what we're going to use is this idea, which is called completing the square. And the crucial idea behind completing the square is that when you have a number that's not a perfect square, then you have some leftovers. So you can write it as a perfect square plus or minus another number. So for example, let's take the number 50. I could write the number 50 in a couple ways. I could write it as, let's remind you, 5 times 5 is just 5 squared. 7 times 7 is just 7 squared. I could write 50 as 7 squared plus 1. It's 49 plus 1. I could also write 50 as 5 squared plus 25. I could also write 50 as, 8 squared. 8 times 8 is 64. So that's 14 too big. I could write 50 as 10 squared minus 50. I hope you see here that I could write 50 as a whole bunch of different perfect squares plus or minus leftover bits. 1 squared plus 49, for example. So there's lots of different ways that you can take a number that's not a perfect square and write it as a perfect square plus or minus some leftover bits. And so what we do now is we look at quadratic equations. So let's take a look at x squared plus 10x plus 25. This turns out to be a perfect square. It turns out to be x plus 5 squared. Now, why is that true? If I draw my little area model, x plus 5 on each side of the square, I get x squared, 5x, 5x, and 5 times 5. So this diagonal here adds up to 10. And that's how I know that x squared plus 10x plus 25 is the same as x plus 5 times itself. Okay? That is the idea of writing it as a perfect square. But what if I had instead x squared plus 10x plus 26? I can't write that as x plus 5 squared, but I can write it as x plus 5 squared plus 1. Why is there a plus 1? Because I needed one more to get to 26. 5 squared is 25. To get up to 26, I need to add one more. If, for example, I had x squared plus 10x plus 13, I could write that as x plus 5 squared minus 12. Where does the minus 12 come from? 13 minus 25 is minus 12. Let's look at a couple more examples here. Let's say I had x squared minus 6x plus 9. This turns out to be a perfect square of x minus 3 squared. Why? Again, if you draw your square and check it, I can say x minus 3 times x minus 3. That's what squared means, that those are the dimensions of the square. That's what squared means. So x times x is x squared. X times negative 3, x times negative 3. Negative 3 times negative 3 is 9. So now I know that if I had x squared minus 6x plus 17, for example, I could write that as x minus 3 squared. 3 squared is 9. So 17 minus 9 is 8. Now, what I hope you've noticed is that every time I'm doing this, the third number I can always make work. The c value I can always make work by just doing plus or minus to fix wherever I'm at. It's actually the b number that controls what goes inside the square. And if you look at how I drew the square, I hope you can see that I took the b value and I cut it in half. Half of b goes there. Because I'm trying to make a square with two equal sides. So I need half of b on one side of the square and half of b on the other side of the square. So we can kind of formalize this process. I'm going to do one more example with numbers, and then I'll show you how we can do it using the letters in general. There's one other wrinkle that I'll get to in the next video, but for here, we're just dealing with the simpler version of the problem. We'll do the harder version in the next video. So let's look at a nasty looking one. X squared plus 7x minus 23. Just nasty numbers here. I can draw my box just to help you visualize what's going on. I'm going to cut 7 in half. Half of 7 is not a pretty number, but that's okay. It's just a decimal, nothing to be scared of. So this is 3.5x. This is 3.5x. Now I got to figure out bottom right corner. Bottom right corner is going to be 3.5 squared. So I just type that into the calculator. 3.5 squared is 12.25. So I take my negative 23, I subtract 12.25, and that gives me the number that's going to go outside the square, 35.25. So now I've completed the square to say x plus 3.5 squared minus 35.25. And the reason that that works is you've got, if you write this out and you multiply it, you'll have x plus 3.5 squared, means you write it down twice. Just showing you why this is valid. If you multiply it out, there's your x squared. There's half of 7x. There's the other half of 7x. There's 12 and a quarter. Combine that with the negative 35 and a quarter, and you'll get back to negative 23. So in this video, I just wanted to focus on a simple version of completing the square. In the next video, we'll talk about the more complicated version of the completing the square. And then after that, we'll talk about how this actually helps you solve quadratics. So please comment if something's confusing. I'm happy to explain more. And thanks for watching.